Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lecture. Before us is a typical examination question, A-level and Cambridge International Examination. So please, I want us to listen attentively and get the best. So the question is on ideal gas equation. Now, when an evacuated tube of volume, the volume of the gas is 400 cn cube, 400 cn cube. So the volume is supposed to be in meter cube, so we'll convert it to what? From cn cube to meter cube. So we'll divide by 1 million. So it will be 400 multiplied by what? 10 raised to the power minus 6. So if I use my calculator, you get 0.0004 meter cube, which is the standard measurement. Then the temperature is filled with a gas at temperature 300 Kelvin, which is T. The temperature is in Kelvin. Then and 101 kilopascal, which is the pressure. The pressure is supposed to be in Pascal, but it's in kilopascal, so we'll convert it to Pascal, which will now be equal to 101,000. To convert from kilopascal to Pascal, you multiply by 1,000. Very simple. The mass of the tube increased by what? The mass of the tube increases by 0.65 gram. Assume the gas behaves as an ideal gas. What is the identity of the gas? So what happened is that what they are trying to ask you is to calculate the relative atomic mass of that gas. Then they're really asking you to calculate the relative atomic mass of the gas. Assume the gas behaves as an ideal gas. So we'll have PV is equal to what? nRT. And remember, number of mole N is equal to what? Mass over the relative atomic mass of that element. So of the gas, or it can be mass over molar mass. So what is the identity of the gas? So, or you can say number of mole is what? Mass over what? Molar mass of the gas. So we want to get the identity of the gas. So if we are to substitute, we'll have PV is equal to what? M, which is the mass over relative atomic mass of the gas, multiplied by what? The gas constant and the temperature. So since we want to get the identity of the gas, we have to calculate the relative atomic mass of the gas. Then you check your periodic table to know the gas that has that particular what? Identity, that have the particular relative atomic mass that you've calculated. So relative atomic mass will be equal to what? Mass multiplied by the gas constant, which is R, multiplied by the temperature, divided by the pressure and the volume. So what we do here now is the mass is 0.65 multiplied by the gas constant 8.31 multiplied by the temperature, which is 300 Kelvin, divided by the pressure, which is 101,000, multiplied by the volume, which is 0.0004. So let me erase this so that I will have enough space. So the atomic mass of the gas will be equal to, so I'm to use my calculator now. So 0.65 multiplied by 8.31 multiplied by 300, you get 1620.45 divided by 101,000 times 0.0004 will be equal to 40.4. So divide, you will now have what? 1620.45 divided by 40.4, which will now be equal to 40.1, which is approximately 40. So what is the density of the gas? So you go to your periodic table and check the gas with relative atomic mass of 40. So it's as simple as ABC, as just very, very simple. So if you go to your periodic table, you look at the periodic table, you check the gas that has relative atomic mass of 40. So, and the answer is what? A is argon. The relative atomic mass of argon is 40, which is, if you go to your periodic table, it is 39.9, which is approximately what? 40. So the answer to this question is what? A, which is what? Argon. So it's as simple as ABC. I'm Mr. Joe, your chemistry teacher. Feel free to reach out to me if you encounter any difficulty. I'm always there for you, and I'll always be there for you. It's as simple as ABC. Solve as many questions as possible. Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Now we're looking at a typical examination question, Cambridge International Examination, on ideal gas equation. Now this is a very simple question. Please, I want us to look at the question very, very. This is a two-step question that has to do with what? Ideal gas equation. It's not the normal, straight jacket question when it comes to ideal gas equation. Now it's as simple as ABC, just the way we eat jollof rice and chicken. It's as simple as that. Now a student reacts 1 mole of magnesium powder in a sealed 0.030 meter cube container of oxygen at a pressure of 2.0 times 10 raised to the power 5 Pascal and a temperature of 600 Kelvin. The magnesium reacts completely to form magnesium oxide. Which percentage of the oxygen will be used up? Now the first thing you do is to write the equation for the reaction, which is magnesium reacting with what? Oxygen, to give you magnesium oxide. Remember, they say it's 1 mole of magnesium, 1 mole of magnesium, 1 mole of magnesium. So you balance the equation. So you put half oxygen here. Now the equation is balanced. Now you are asked to calculate the percentage of oxygen that will be used up. The percentage of oxygen that will be used up when 1 mole of magnesium powder in a sealed 0.030 meter cube container of oxygen at a pressure. So this is the pressure, which is P. This is the temperature, which is in Kelvin. Pressure is in Pascal. And this is the volume, which is in meter. So applying the ideal gas equation, we'll have PV is equal to what? nRT. P is the pressure, V is the volume, N is the number of mole. So we're going to calculate the number of mole of oxygen inside the sealed container, the number of mole of oxygen. So number of mole will be equal to what? Number of mole will now be equal to what? PV divided by what? RT. You make number of mole the subject of the formula, which is PV divided by what? RT. So the pressure is what? 2.0 times 10 raised to the power what? 5 multiplied by the volume, which is in meter cube, 0.030 divided by the gas constant, which is 8.31 multiplied by the temperature, which is 600 Kelvin. So we want to get the number of mole of oxygen in the container. A student reacts 1 mole of oxygen powder in a sealed 0.030 container of oxygen at a pressure of 2.0 times 10 to the power 5 Pascal and a temperature of what? 600 Kelvin. So to calculate the number of mole of oxygen, it will now be equal to 2.0 times 10 raised to the power 5, then times 0.030. So you have number of mole of oxygen is equal to what? This is the number of mole. So we'll have 6,000 divided by 8.31 times 600. 0.31 times 600. You have 4986. 4986. So the number of mole of oxygen will now be 6,000 divided by 4,986, which will now be equal to 1.2. So 1.2 moles of what? Oxygen. So you have 1.2 moles of oxygen. Now you are asked which percentage of oxygen will be used up. So the entire number of mole of oxygen in the container is 1.2 moles of oxygen. And the number of mole of oxygen you use up is half mole of oxygen, which is 0.5 mole of oxygen. So I'm to erase this, then I'll put the right so that I'll have enough space. So to calculate the percentage of oxygen that will be used up, percentage of oxygen used up will be equal to what? Number of mole of oxygen, which is used 0.5, divided by what? The number of mole of oxygen in the container, which is 1.2, multiplied by what? 100. So you now have 0.5 times 100 will be equal to 50, then divided by 1.2, 0.5 times 100 divided by 1.2. So now divided by 1.2, so you have 41.6, which is approximately what? 42. So percentage of oxygen used now will be equal to what? 42%. So it is 41.6, which is approximately 42%. So the answer to this question is what? C. So as you can see, it's as simple as what? A, B, C. So all you just need to do is to read the question, understand the concept, and then you solve the equation. So I'm Mr. Joe, the chemistry teacher. So feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'll be there to help. Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Now, for us is a typical examination question on ideal gas equation. This is an A-level question, Cambridge International Examination. Please, I want us to pay attention and listen attentively. So the question before us, at a temperature of 2500 Kelvin and a pressure of 1.00 times 10 raised to the power minus 4 Pascal, a sample of mass 0.321 gram of sulfur vapor has a volume of 2.08 times 10 raised to the power 6 meter cube. So what is the molecular formula of sulfur under this condition? Now applying the ideal gas equation, so what they are trying to tell us here is to what? Is to calculate the molar mass. Once you calculate the molecular mass of sulfur, we can get the molecular formula under this condition. So applying the ideal gas equation, we have PV is equal to what? nRT, and P is the pressure, V is the volume, N is the number of mole, R is the gas constant, T is the temperature. So number of mole is equal to what? Mass over molar mass. So if we are to substitute it, that means PV now will be equal to what? Mass mRT over what? Molar mass. So if we are to make the molar mass the subject of the formula, the molar mass now will be equal to what? The mass multiplied the gas constant multiplied by temperature divided by the pressure multiplied by the volume. So molar mass is equal to what? The molecular mass will be equal to mRT over divided by what? P, which is the pressure times the volume. So I'm going to erase this so that I'll have enough space. So we are to calculate the molar mass so that we can get the molecular formula of sulfur that is under this condition. So molar mass now will be equal to the mass of the sulfur is 0.321 multiplied by the gas constant 8.31 multiplied by temperature 2500 Kelvin divided by pressure 1 times 10 raised to the power minus 4 Pascal multiplied by 2.08 times 10 raised to the power 6 meter cube. So mR molar mass now will be equal to, if I'm to use my calculator, 0.321 times 8.31 times 2500 is equal to So you have 6668.775 divided by the pressure, which is 1.0 times 10 raised to the power minus 4 times 2.08 times 10 raised to the power 6. So you have 208. So the molar mass now will be equal to, so 6668.775 divided by 208. So you now have what? 32.1. So the molar mass, the relative molecular mass of the sulfur is equal to 32.1. So you look at it, you go to your periodic table and you check the relative atomic mass of sulfur. So from your periodic table, the relative atomic mass of sulfur is 32.1. So the molar mass of sulfur is 32.1. Sulfur is equal to what? 32.1. Therefore, the molecular formula of sulfur under this condition is what? S, which is A. So the answer to this question is what? A. So it's as simple as what? A, B, C. So A is the correct answer. So attempt as many questions as possible and feel free to reach out to me if you encounter any difficulty. Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lecture. Before us is a typical A-level question on ideal gas equation. And the question goes, 1.8 gram of water heated to 227 degrees Celsius in a sealed container. There's a change of state here from liquid to gas, turns to steam, which is water vapor with a pressure of 200 kilopascal. What is the approximate volume of the container? The approximate volume of the container, I think, is the volume of the gas, because gas molecules are always in constant random motion, colliding with themselves and also with the walls of the container. So once heated, they occupy the entire container, because they are always in constant random motion. So basically, just a change of state from liquid to gas, which is still water. Water, steam is H2O. Water as liquid is H2O. So it's still the same formula. So we are to apply the ideal gas equation. So I believe what we are asked to calculate here, which is the volume of the container, is the volume that the gas would occupy. So PV, using the ideal gas, PV, ideal gas equation, PV is equal to what? nRT. PV is equal to nRT. So P is the pressure of the gas, which is in Pascal. The pressure must be in Pascal. If it's in kilopascal, you convert it to what? Pascal, which is the standard unit, which will now be what? 200 kilopascal is equal to 200,000 pascal. 200,000 pascal. You multiply by 1,000, so you get 200,000 what? Pascal. That is the pressure. Then the temperature, which is 227 degrees Celsius, you convert it to Kelvin, which is 227 plus 273 Kelvin. So you have what? 500 Kelvin. Yes, you have 500 Kelvin. Then applying the ideal gas equation. So P is the pressure, V is the volume of the gas, N is the number of moles, R is the gas constant, T is what? The temperature. So what we have to do is to calculate the number of moles. Number of moles of the gas is equal to what? Mass over what? Molar mass. The mass is 1.8 gram. Out of 8 gram of water, which is the same what? 1.8 gram of the water vapor, which is steam, divided by the molar mass. Molar mass of water is H2O. So hydrogen is 2 bracket 1 plus 16. So 2 plus 16 is equal to what? 18. So the molar mass is what? 18. So the number of mole will be equal to what? 1.8 divided by 8. I'm to use my calculator here. 1.8 divided by 18. 1.8 divided by 18, which is equal to, you have 0.1 mole of steam, which is the gas. So to calculate, we have to calculate the volume. So what we do, you make V the subject of the formula. The volume now will be equal to what? Number of moles times the gas constant times temperature divided by what? The pressure. So I'm to erase all this so that I will have enough space for me to solve. So volume now will be equal to number of moles is 0.1 multiplied by the Gauss constant 8.31 multiplied by the temperature, which is 500 Kelvin, divided by the pressure, which is 200 Pascal, 200,000 Pascal. So the pressure is 200,000 Pascal. So to use my calculator, I will have what? 0.1 times 8.31 times 500 is equal to divided by 200,000 Pascal, which will now be equal to what? 0.00207 watts, 207 meter cube. So in standard form, it will now be 2 times 10 raised to power what? Minus 3 meter cube. So the answer to this question is what? B, which is 2 times 10 raised to minus 3 meter cube. So as you can see, it's as simple as ABC. So just attempt as many questions as possible and reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So have a nice day. Thank you. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.